Implementing a scalable remote access solution. This is a fairly complicated topic and involves two broad remote access technologies, VPNs or virtual private networks, and Microsoft's direct access technology as implemented in Windows Server 2012. I'm going to walk you through some of the major design aspects, things you need to think about, as well as some of the broad strokes of the configuration so that you can see where those things are and understand what you have to have in place before you begin. We've got quite a few configuration things to get through, and we're going to focus mainly on the processes and the decisions and the prerequisites that need to be in place. Not so much the actual buttons you have to click, although I'll walk you through portions of those processes. We'll specifically be looking at site-to-site VPNs, as well as VPN packet filters and tracing. Remote access with an emphasis on the multi-site configuration, which is a little bit more advanced and has a lot more prerequisites than a single site. We'll be layering a little bit of the basic outlines of direct access configuration on top of that, and talking about how to set up network load balancing with an idea of load balancing your incoming remote access connections across multiple remote access servers. So this is really all built around the Windows RAS, or Routing and Remote Access Service, one of the roles that can be installed on Windows Server 2012. And we're going to be walking through several different scenarios. A lot of these scenarios are going to involve an external user, or not external, I guess, an outside user, somebody working from home or maybe from a hotel room, coming into your network via RAS. But that's not where we're going to start. Where we're going to start is the classic site-to-site connection, where you're essentially taking two separated sites that don't have a connection to each other, but are both connected to a common public network, the internet, in other words. And we're going to set it up so that a user on one of these can traverse RAS over the network, securely, of course, hit the RAS on the other machine, and then essentially be on this network, access resources on this network as if they were located here, or as if the two networks were connected by a virtual private network, which is what VPN, of course, stands for. So let's get into that scenario first, and then we'll start talking about some of the more client remote access type scenarios. Now, since the service we're playing with is routing and remote access, we are going to start in the routing and remote access console. Get this up and running. You'll notice that on a new server, and this, by the way, is a set of steps you're going to have to complete on the RAS servers in both locations. So both ends have to be configured. When you launch this for the first time after installing the RAS role, you'll notice that it's not configured. That's why you get the little red down arrow. So we're going to configure it. Just a right click and configure. You need to decide how you're going to use this RAS server, and it's entirely possible to use multiple different scenarios here, and that's what the custom configuration would let you do. As we talk about a scalable RAS situation, though, something that's designed to work with a lot of traffic, I find that people tend to dedicate each RAS server to just one purpose. Now, for one, they get better performance that way because the RAS server can focus on doing just one thing, but they also kind of spread their risk out a little bit. If a server fails or something goes wrong, you're not taking down several different services, you're only losing one. So I'm going to configure this for just one service, which is a secure connection between two private networks. Now, this next dialog can be a little bit confusing. When it says demand dial connections, it does not mean dial-up. I mean, we're not talking like a phone line or an ISDN modem necessarily. That is one type of demand dial connection. I'm going to say yes. How do I want IP addresses to be assigned to remote clients? Let's just do it automatically. We'll talk about that configuration bit when we get there. Now, RAS creates a connection request policy, and it names it Microsoft Routing and Remote Access Service Policy, like it says here. Your network policy server, part of network access protection, which is something that we'll be talking about in a couple of nuggets from now, that also uses connection request policies, and you do not want a conflict between them. So this is simply warning me to open the NPS console and verify that everything's configured properly and not conflicting. Now, I don't have any policies configured in there, so I'm not going to worry about that right now. And that icon is a sure sign that this technology dates all the way back to NT4, at least the dialog box. The little ticking clock. Okay. Now, because I said I want to create a new demand dial interface, it's going to do that. So we're going to call this the Georgia office. And I'm going to connect to that office using a VPN. You'll notice that my modem, ISDN adapter, or other device is grayed out because I don't physically have one of those connected to this machine. So it's only offering me the other two. This is where you need to decide what type of VPN you're going to create. And I guess we should spend just a couple of seconds kind of talking about the differences between them. PPTP, in addition to being fun to say, stands for Point-to-Point Tunneling Protocol. Now, people kind of have the impression that this is a Microsoft proprietary protocol, and that's not the case. It was actually specified by a vendor consortium that did include Microsoft, but also, at the time, Ascend Communications, 3Com, and some other folks. It is an encapsulation protocol. It's designed to take the old dial-up point-to-point protocol and encapsulate it using something called general routing encapsulation. Sort of the practical comparison upshot is that PPTP is relatively easy to get through most firewalls. It is not the most secure thing in the world, as it relies primarily on shared secrets or passwords for its encryption. And you can, if you're capturing packets, kind of tell that this is PPTP happening, and that could potentially give an attacker a leg up on actually cracking through your whatever encryption you apply. The PPTP protocol itself does not specify encryption. It also doesn't specify authentication for that matter. It just specifies the tunneling portion of it. And so PPP is what actually has all of your security features built into it. So, I mean, this is still a very valid VPN protocol. It's still used by a lot of folks out there. It's a little bit of an older protocol, but it still gets the job done. Now, the next option we saw there was the Layer 2 Tunneling Protocol, or L2TP. Again, this only specifies tunneling, and we'll talk in just a second about what I mean by tunneling. This does not specify any encryption, but whatever traffic flows through the tunnel can be encrypted, and RRAS does take care of that. L2TP is a little bit more cross-vendor. It's definitely supported by a wider range of vendors than PPTP. It is considered more secure, although that's mainly because, again, the technologies used to apply encryption within the tunnel tend to be a little bit more modern. So that's also an option. It used to be pretty hard to get that through firewalls because of the way the packets were constructed, but these days that's largely been taken care of. It's rare to find ISPs that won't pass that traffic. And then the last one we saw was IKE. Now, IKE stands for Internet Key Exchange, and it consists of a couple of protocols, the Oakley protocol and the ISACAMP protocol. All of this really comes from IP security, and it uses X509 digital certificates, encryption certificates, to provide authentication. Those can either be pre-shared, meaning you install the certificate on both ends prior to embarking on this process, or distributed with DNS, preferably DNSSEC, so that they're secured as well. You can have a key exchange set up to set up shared session secrets, and cryptography keys are then derived from that. So this is considered a very secure protocol. It is much, much more standards oriented, but it does require a lot more work to set up. For our purposes, other than needing to be able to distinguish between these different varieties, they all kind of have their own little configuration technique, but they're largely similar. We're going to focus on that dude. But before we do, let's talk a little bit about a common word between those three protocols, which is tunnel. It's really what we're doing. Between these two RRAS servers, we're creating a tunnel. And the traffic from these networks will pass within the tunnel. And the idea of the tunnel is to make the public network look like it is a private point-to-point connection between the two RRAS servers. So lots of different traffic from lots of different sources on this network can all squeeze through this tunnel, just like a multi-lane tunnel that goes under the harbor that all the cars squeeze through to get from one side to the other. Everything squeezes through here and then goes out to wherever it's going to go on the remote network. So the real difference between, say, PPTP and L2TP is the protocol they use to construct this tunnel. The tunnel itself isn't necessarily encrypted, but in conjunction with building that tunnel, you typically do encrypt things and decrypt them. So as things start out here, they get encrypted at this point, flow through the tunnel encrypted, and then get decrypted there. The idea is to really make this entire setup as transparent as possible to everyone except the two RRAS servers. They're the only ones that really know anything's going on here. They're the ones taking care of applying the encryption, wrapping it in the tunneling protocol, and shipping it across the network, receiving it on the other end, decrypting it, and then putting it onto the local network on the other end. So that's why these are referred to as tunneling protocols. Now back in the product, you'll notice that the default selection here is automatic selection, meaning our server is going to talk to the other server and try and figure out what protocol it supports, and the two will magically select something between them. That sometimes works. I'm a little superstitious, so I'm just going to focus straight on PPTP. I do need to provide the IP address or the name, the DNS name of the router on the other end. Now, because we want this to connect over a public network, it needs to be a public IP address or a host name. So I am actually going to go with, let's see, I'm going to need to look this up on the other end. Hang on a sec. I think I can actually pull this out of my DNS console because this is my machine. Go to DNS, forward lookup zone, and I want to look for lots of signatures. I just passed it. There it is. 10.0.0.85. I am actually traversing this across a private network because I've got both of these machines set up in a lab. So 10.0.0.85 is what I want to do. Now, this is kind of important, and I'm going to talk a little bit more about the routing piece of this in just a second. I do need to route IP packets on this interface. That has to be done because I'm taking things off of my local network and routing them to the remote machine. I don't necessarily need to add a user account so that the remote router can dial into me, but it is not a bad idea. You see, these VPN connections are kind of built and taken down dynamically. So as a person in one office tries to reach a resource in the other office, the RRAS servers will figure that out, and they will bring up the VPN connection on demand. That means I technically want both sides to be able to initiate the connection. So I now need to decide what static routes I'm going to create. Let's talk about this for a second too. This definitely bears discussion. And to do that, let's put some numbers on our diagram. Let's assume that this network over here is a single subnet that uses 10.0.0. something. This one uses 10.0.1. something, and this one uses 10.0.2. something. So when a client on the .2 network needs to access a resource, they look up its name in DNS, they get an IP address, and if it is also on the .2 network, then they know they can just broadcast traffic to it, thusly. If it's not on the .2 network, if it's on any other network, then the client sends the packet to its default gateway, which is typically a router. This router needs to know where every single network can be accessed. It needs to know where the .0, the .2, and the .1 network live. It needs to know that the correct route to get from the router to the .1 network is this way. It needs to know that the correct route to get to the .0 network is this way. And so how you configure your routing is going to depend a lot on the construction of your network. Now over here, where we've just got a single subnet and no routers at all, it's probably fine to schedule static routes in this RRAS server telling it that the .1 and the .2 networks can be reached via its VPN interface. That might not be as simplistic over here though. This RRAS server certainly needs to know about the location of the .0 network. But this router is also going to have to be configured with that information, and there's really two ways for that to happen. The first way is for that router's administrator to go in and program a static route, saying, to get to the .0 network, go to this gateway, essentially treating this as a second router on the network. The problem with static routes is that they can be outdated over time. If somebody sails in and reprograms this network and says, now this is going to be the 10.1.3.x network, all of a sudden, all the static routes are no good anymore. And if you don't go fix them all, then the network will quit working correctly. So rather than static routes, it's also possible to use a routing protocol. And there's a couple: RIP, open shortest path first. There's a few of these, and RRAS does speak some of those protocols. We'll take a brief look at where to set that up or where to configure those things. But essentially what it lets RRAS do is say, look, I already know about this interface and what it leads to because it's a VPN and I've been configured with it. I'm then going to share that information with the other routers that I find on the network so that they will know I am a route to that remote network. And if IP addresses change, then the routing table, the protocol, takes care of rebroadcasting that information so that everyone's tables get updated. Just keep in mind that simply configuring RRAS is not sufficient if you have other routers on your network, and you're almost certainly going to have other routers on your network. Those routers need to know about the remote routes somehow, and they can either pick it up through a dynamic routing configuration protocol or via static routes. Now, in order for this demand dial connection to be activated, I have to have at least one static route that tells it what's on the remote end. So on the destination, we're going to say the destination network uses 10.0.1. whatever. I can just put a 0 here because I'm going to give it a network mask that tells it which bits of this actually matter. And I'm going to say that this has a metric of 1, meaning because this is the only way to get there, I don't need to worry about the cost. But if there are multiple routes to get to a network, then IP will tend to choose the lowest cost based on this metric. Now keep in mind that this address is not necessarily going to be the same as the one that we entered as the destination, and that's because your RRAS server has 2 ends. This is the address this machine will dial into, but these are the addresses that need to go into the route, meaning this interface is the way to get to this network. So just kind of bear that little difference in mind as you're typing in all those addresses. So there we've got our one static route. We'll continue. It's going to default to creating a username that's the same as whatever I named this demand dial interface. And I'm just going to put in a simple password that's easy to remember. Password. Now, what credentials am I going to use to connect to the remote machine? Well, when I set the other connection up, I plan to call it Vegas Office. So that's what I'm going to create it as. That's going to be in my same company domain, meaning there's a domain controller over there that can authenticate the Vegas Office user. And I'll put in the password that I plan to create over there. And I guess I didn't type that right. There we go. Okay, that's all finished. Let's let that create it, and then we should be able to flip over here in our network interfaces and see the Georgia office, and you'll notice a little icon has a little tiny telephone on it, telling it that this is a demand dial interface, which it also says here, and that it's disconnected. This is designed to connect automatically, but let's just dig into its properties for just a second. I could manually connect it. I can change the credentials, do some other stuff here too. I can set its hours. Now let's say that we're I don't know, paying per use on the actual connection that's between these two offices, and I only want it to work during certain times. I can do that. We're going to look at some of the other things I can do, as well as including dial-out filters and so forth and what those do. Let's just take a quick look at the properties. This is who I dial to get there. It is demand dial. I could, at this time, change it to a persistent connection, meaning when RRAS starts, it's going to try and bring this up and leave it up all the time. Security, it's point-to-point tunneling protocol. I want to require encryption, and I want to disconnect if the server on the other end can't come to an encryption agreement with me. And for authentication, I'll allow either of these protocols. From the networking side, I'm going to route IPv6 and IPv4 across it. That's fine. So I can then connect this whenever I want to. Now, if we get over here into the IPv4 section, we should be able to see the static route Maybe I put that in here. Oh, nope, that it doesn't exist yet because the interface isn't up, so that's totally fine. And what I can do is instead of relying on static routes, I can set up a new routing protocol. The only one I currently have installed is DHCP Relay Agent, so I'd need to go back into Server Manager and install another routing protocol if I wanted to, and that's where you would go to do that. So that's the basic setup of getting one of these things working. Now, whenever this RRAS machine receives a packet destined for that remote network, it will attempt to spin up this connection, route the traffic over there, and then when some idle period of time passes and it's no longer using the connection, it will take it down again. I do have to go over to that other office and set up that basically perform those exact same steps and just reverse everything so that the reverse office knows which networks are reachable on this end, what IP address to dial on this end, and that it has the proper user account set up. So simply running through that wizard again on the remote server will set all of that up for me. Now, we're not actually going to run through that. That's a kind of a lower level configuration detail at this point. And we've got several other things we need to cover. And the first of those are packet filters. So going back to my network interfaces, select, and you got to make sure you're on the right tab over here. You don't, even though your interface shows up under the IPv4 and IPv6 section, you get a different context menu when you right click this thing as shown. Let's see if I can get it to do it. There we go. This is designed more for the routing piece. So up here on network interfaces, demand dial filters. In other words, what traffic will cause this connection to occur? Right now it's everything. And what traffic won't? So to set this up, and you'll notice that you get a couple of grayed out options here. Those will stop being grayed out once I add a filter. And the idea is that by default, all traffic will bring up the connection except the filters I list here. Now, once I start listing filters, I can change that by picking this radio button and say only this traffic that I list here will cause the connection to come up. And this allows you to exercise some controls. And it's pretty simple. You would say that, let's just punch in a local address on my end here. Oops. The IP address in the subnet, oh, right, because I gotta have a 0 there. Duh. So only source addresses with a 10.0.0.something, because of my subnetwork mask, are allowed to bring this up. And furthermore, they're only allowed to do it when they're attempting to talk to port 80 on the remote end via TCP. So basically, someone on my local network who's trying to hit a web server on the remote end can bring up this traffic, and no one else can. Nothing else will cause it, because I've changed this to say that only this traffic will bring up that connection. And so packet filters just really do allow you to exercise some basic controls. This isn't intended to be a per user thing. There's no authentication piece of this. It's strictly a packet analysis. And it says that only this type of traffic will or will not be routed across that particular connection. Now, I'll tell you the thing that from a troubleshooting standpoint can be a little confusing, at least problematic, is that nowhere on this screen does it show you that there are any filters set up. Nowhere in here will you see any of those filters. The only way you're going to notice them is by going in here, right-clicking, and looking at demand dial filters. And notice that you've got separate ones for IP and IPv6. Now, because I don't have IPv6 installed on that interface, I can't set up a filter, but they are a separate dialog for each of them. So from a troubleshooting perspective, don't ever forget to go in and look at those things, because it's real easy for it to be doing something devious in the background and not surface at all in this console anyplace else. In fact, while we're on the subject of troubleshooting, one of the great troubleshooting tools in RRAS is its extensive ability to create trace logs. Now, this isn't quite the same thing as a packet capture, although it's really darn close. It shows you all the decisions about traffic that the RRAS server is making. You got to turn this on, because on a high volume RRAS server in particular, it can generate enormous trace logs really, really fast. So you want to You want to turn this on when you need it and then shut it back off again. So it can be done from the registry or the command line. I am scared of editing the registry, so I find the command line is a lot easier. And we are going to type netsh ras, which is the component we're modifying, set, and then the particular bit that you want to set. There's a number of different components that can be done through here. Tracing, and then the name of the actual component that you want to trace. Me, big fan of tracing everything, so star enabled. And then when you're finished, disabled shuts it back off again. So I would be remiss, though, if I did not open up Registry Editor and at least show you where to find this thing. So let's start all the way at the top here. We're going to look in HKey, local machine. We are going to go to software. From there, we're going to go to Microsoft. And from there, we're going to go to tracing. LMNOPQRST tracing. And so these are all those different components. Where I hit star, I turned on every single one of these. So if you just needed to turn on a certain one, well, I didn't turn on all of these actually. I turned on all the ones that have to do with RAS. So you can turn on RAS authentication, extensible authentication protocol. You got point-to-point protocol here, RAS manager, user. All these different bits can be turned on for RAS. And then you'll notice that when you turn them on, this enable file tracing gets turned on, and this tells you where it goes. So let's quickly look and make sure there's a folder there. It'd be under C, Windows, element of PQRS tracing. So nothing in there because I haven't done anything with it, but that's where your actual trace log files would wind up once you had turned tracing on. Keep in mind, this really consumes resources. I've seen administrators turn this on for everything, spend some time troubleshooting a problem, get called away to deal with some other priority, forget that they've turned this on, and act all surprised about it when there's suddenly mega gigabytes of disk space being taken up a week later because this poor thing is still pounding data into those trace files. On some machines that I've seen, it does create a noticeable performance impact. If a machine is already kind of at its limit and it's getting a lot of traffic through, that creates a lot of extra disk traffic, which is the slowest thing in the world on top of that. And it can take a machine over the edge if it's already kind of close to it. So just, exercise a little caution. That's all I'm saying. Okay, we're now going to start talking about multi-site. And in fact, I'm going to deconfigure. Oops, this is DNS. Good, that's where I wanted to be. And I need to go into my routing and remote access. I want to really quickly make sure I've deconfigured because we are going to be starting very much from scratch for this multi-site stuff. And this is where we're going to start overlapping into, yep, I do need to deconfigure. This is where I'm going to start also overlapping into direct access configuration. So these two things are kind of all about client computers getting into the network from afar. All right, so that's the RAS piece. Let's get into DNS because stray wizard hanging around. Because this is our first step. So the first thing we need to do, direct access includes a network location server, which is a website that is used by clients, direct access clients, to decide what they're going to do. So we're going to start by opening this DNS console here. We're going to right-click on our domain and create a new host. This is the name of the server where this doohickey will be running and its IP address. And I don't actually know my IP address, so let me just get that real quick. Internally 10.0.0.81. Awesome. Go away, go away, go away, go away. All right. 10.0.0.81. Click add host. Great, it was created. Now we're going to create another one. And we're going to enter the DNS name for the web probe, and the default web probe is direct access minus web probe host. So we're going to use this because it's what direct access is configured to query already. So we're going to enter the same one, 10.0.0.81, enter add host, and click OK. Let's close this. I want to refresh this real quick and just make sure that those things showed up. DC should already have had one in there, but I'm looking to make sure that web host got it. Okay, great. And then there's my direct access one. There it is, web prep host. Awesome. And that's signed and everything else. Now there's a couple of other steps you'll have to take, and this is how you do this is going to depend on how your particular infrastructure is configured, but your direct access clients must be able to resolve the DNS name of the remote access server from the internet, which kind of makes sense. They're going to connect to it, so they have to be able to type its name and resolve that to a public IP address that they can get to. Also, because certificates come into play here, direct access uses certificate revocation checking for the HTTPS connection between direct access clients and the remote access server. It also uses certificate revocation checking for the HTTPS-based connection between the direct access client and the network location server. And in both cases, direct access clients must be able to resolve and access the certificate revocation list, the CRIL distribution point location. This is pretty much given to you if the certificates you request come from a commercial certification authority, someone like VeriSign or CyberTrust or whatever else. If your certificates are being issued by an internal CA, then the CRIL distribution point must be accessible from the internet, and you've got to have the right publicly accessible DNS records so that clients can find the distribution point so that they can access it. Now, a couple of other quick points. All of the computers, your clients as well as the remote access servers, need to be domain joined. And they need to be joined either to the same domain or to trusting domains. Another thing that's easy to overlook, CRILs. Direct access uses certificate revocation lists to check the two different types of SSL certificate it's going to get. One of which is the HTTPS connection between the direct access client and the network location server, and another which is the HTTPS connection between the client and the RAS server itself for the actual traffic. So if you've acquired those SSL certificates from a public certification authority, VeriSign, CyberTrust, whoever's out there these days, this all gets taken care of for you. If not, your internal CA, if that's where you got your SSL certificates from, needs to have its CRIL published to a publicly accessible distribution point, and the certificates and DNS have to be configured so that clients looking at a certificate can figure out how to get to that distribution point. So make sure you've dealt with those couple of minor issues in your infrastructure. So now I'm going to walk you through the process of configuring direct access and multi-site. There's a lot of pieces of this. I want to introduce you to the pieces. I want to show you the main places where people get tripped up. I'm not necessarily going to walk through the entire process, and you're going to see why in a second. There's a lot of little details that are going to be very specific to your environment that you need to have kind of in hand ahead of time. So let's just, we'll do the get started here. So I've already got my DNS set up. I've got my user group created. I've figured out all the IP addresses and everything that are going to come into play. So the next thing is to come down to the remote access manager. This is a new console. This is different from the routing and remote access console. And we're going to run the Getting Started wizard. You've got two modes you can run this thing. You can say, I only want clients to be VPNing into my environment across multi-site. I only want them coming in via the direct access technology, or both. I'm going to start with the both here. You have to decide what your network topology looks like. It will try and take a guess. And what I'm telling it here is that the remote access server is deployed at the edge of the network, configured with two adapters. One goes straight to the internet, the other goes to the internal network. Type the public name or IP address that clients are going to use to get to this server. Doesn't really matter what you type here, and I'll show you why in a second. Well, it matters what you type. Doesn't matter what I type here. Here's the trick. In order for this thing to make it further, you've got to have an external adapter that has a public IP address, an IPv6 enabled, and does not have a domain profile. And that's the tricky bit. Now I'll show you what happens if I switch over to this one, and I'll do it again. So now it's not able to find an external adapter that has any valid IP address. What I've done now is I've said I'm not the edge device. I'm behind a firewall. So don't look for one of my adapters to have a public IP address because I'm not going to have one. I'm on a DMZ and I'm behind my firewall. That's going to be passing things through to me. And this domain profile becomes the trick again. Now I'll change this one more time. You'll see that I'll still probably get the roughly same. Oh, well, now it's going to walk through it, of course. Before we go any further, I want to show you what all that fuss was about. If you go in your network and sharing center and you look on the screen, you'll notice that I've got one network that I'm connected to. And although I do have two network adapters, they both think they're connected to my domain network. If you're looking at the network and sharing center on the RAS server and you see this, then you're not going to be able to get one of those first two to work. What you've got to have is an active network on your domain network, of course. So this is your internal NIC, but you've got to have another one of these blocks that says public network. It has to recognize that one of these things is not hooked up to your internal network. It's got to think that it's hooked up to a private network, to the public network. Without that, you'll never be able to get one of those first two options to work. That's what that was saying by domain profile. This is a domain profiled network, this company.local, that it sees itself connected to. So, okay, now I've told it I only have one network adapter. And here's I guess it would be helpful if I kind of outlined the scenario here. So let's get Visio up full screen for you. What I'm telling it now is essentially what's pictured here. I've got my RAS server, and presumably I've got a network connection that goes out to the internet, and presumably there's a firewall on that. My RAS server has one network adapter, and to get to the firewall, it goes through my private network. So I'm expecting this to be a domain-connected network profile because it's connected to my domain network. And so that's why in single adapter mode, it's going to let this work. All right, so let's finish that. This is actually creating my group policy objects now. Creating some DNS entries for my network location server certificate. You get a whole little checklist of everything it's doing. I love these new graphical user interfaces where they do this. So I like the SQL Server one this reminds me of. All right, so as it skips through this list, you're going to see some of the problem areas. And this is because I deliberately borked the DNS information on this interface to get this. Every place here you see that it's trying to, stop that. Every place you see it's trying to create a DNS entry automatically for me is where it failed. And that's okay, because I showed you where to go create those. And this wizard actually is pretty good about telling you need to create them. So those are just warnings. This will all still work so long as you go through and do what it says, which is manually create the entry, add the entry manually. So let's just go through and make sure everything else was okay. This looks like it did apply the GPOs. Yeah, it looks like everything else worked. Okie dokie. Now, the reason it's saying I can't get to the settings is because I don't have access to the GPO, and I'm reloading and confirming that's true. So let's just go into GPO management for a second and see what it did. Can't get to my domain controller. Let's try that again. There we go. A little refresh action. Okay, so you can see now that we do have GPOs that have been created, direct access server settings and direct access client settings. Let's see if I can get this to reload now. Yeah, there it goes. Just had a little momentary IP flub. So this is where I will edit my client computers that are enabled. This is where I will define the configuration settings for the remote access server. I can identify the infrastructure servers that are accessed by direct access clients, and then application servers. So there's all these extra little steps you can use to configure this. Now, the key that we're really going to focus on is over here on Enable Multi-Site. And what this is telling me is that IPsec authentication has to be configured to use client certificates, which is on the authentication page of the Remote Access Server Setup Wizard. So that's here. And what this is going to do is just show you some of the steps that's going to take. Right. Now, I'm telling it to use a self-signed certificate to authenticate IP HTTPS connections. You probably don't always want to do that, particularly in a multi-site arrangement. Let me show you where you would go. MMC. Let me make sure I get this in. Remove snap-ins, certificates. Focus on the computer account on the local machine. Right-click, all tasks, and this is where you're... Dang it, stop that. Click on one of these things. So on the personal certificates, right-click, all tasks. There we go. Request new certificate. This will generate a certificate request that you can take to a certification authority, get an SSL certificate, and then bring that back and install it on this machine. Once you do that, that certificate will become available through this browse dialog. That's going to be necessary because you don't want your clients having to trust each server, right? When you go through to do the multi-site setup, you want them to all be able to use the same certificate. So that's really the key to this. Once you go through and set that up, I'm just going to next finish my way through here. Using computer certificates, enable Windows 7 client computers if you need to. Once you do all those things, then you'll be in effectively multi-site mode. It means that a user will be able to authenticate consistently to any entry point on the network, no matter where it's located, and you can set up global load balancing, and that's what this stuff over, and that's the next thing we're going to talk about actually, so that multiple different entry points on your network can all be kind of load balanced across each other for both fault tolerance and for workload. So I'm going to close this console because I feel that I have a lot of consoles open, and I want to shut some of these down so we can kind of get a fresh start. Is that everything? All right, good. All right, so the technology we're talking about now is network load balancing, NLB. That's a specific feature that gets installed on Windows Server. Unlike a hardware load balancer, which essentially is literally it's a piece of hardware that has its own IP address, and when people come into it, it has a list of IP addresses that it distributes load across. NLB doesn't work quite that way. Instead, you create a cluster by installing NLB on multiple servers. Now, each server has its own IP address. Let's say this is 10.10.10.2, and this one over here is 10.10.10.3. NLB gets its own IP address, 10.10.10.10, let's say. That's what you point clients to. That's what goes into DNS. Both of these will respond to that IP address, and they'll do it independently. In other words, there's no communication between them really. They're both just deciding which ones they will respond to based on a statistical load balancing algorithm. There is conversation between the two. They keep track of whether or not they're healthy. There's kind of a heartbeat that flows between them. And if one of them dies, then NLB on the other one says, well, okay, I'll start responding to all the requests instead of just about half of them. So this is software-based load balancing, and it works fine with routing and remote access. In Server Manager, you have a specific NLB console, Network Load Balancing Manager. I have not created a cluster here, so I get nothing showing up, but I can create a new cluster. I need to pick this host, so I'm going to connect to it. I don't have NLB installed. What a bummer. That means we're going to have to go back and add the role. And this is typically a feature. I just want to make sure I'm not missing it on this page first. A, B, C, D, E, F, N, L, load balancing. There we go. I don't think I have to restart on this one. It's important that if you have servers that are using NIC teaming, that you understand how your hardware's NIC teaming feature will play with this. Typically, NIC teaming is reasonably transparent to Windows. Okay, that finished good. And so it's two cards that respond to one IP address. That becomes the local IP address, and then you have yet another NLB IP address that sits on top of that. So now let's see if I can connect and create a new cluster. There we go. You can configure a priority for these guys. And the priority kind of simply specifies who's got how much of the load. And you can use that to kind of offset dissimilar hardware. If you've got one machine that you want to take most of the load, then you can set the priority accordingly. You can have whatever IP addresses on here you want as part of this NLB. I want this to start by default, but retain a suspended state after the computer restarts. So if I have suspended it and restarted the computer, and now I need to add my cluster IP address. I could choose to add an IPv6 address or generate one automatically if you're playing the IPv6 game. So this is my configuration, my full internet name. We're just going to put cluster.company.local. It's going to operate in unicast mode. I'm not going to set up any port rules. In other words, I'm going to let all traffic be load balanced here, and that should do it. So essentially what I have right now is a single node cluster, and that's completely legitimate. A two-node cluster with one failed node is also a sort of a one-node cluster. Once this is set up, you can start using this as part of your remote management. So, okay, good, that's finished. And now if we go back into the remote access manager, I'm just waiting for this console to finish loading. Okay, and we can click on configuration, and now if we wanted to play with load balancing, we could do that. Now this again has a lot of requirements that come up front. It needs to be able to get the adapter information. It needs to be able to talk to the computer, so you've got to configure all that, make sure everything networking-wise is working first. I like to, maybe play with NLB at a lower level first with a different service, make sure it's properly balancing traffic between all your nodes, get NLB set up on all your nodes, get the cluster built, and then you can dive into the load balancing. Once you do, it's pretty straightforward. You're just going to walk through. There's not a lot of options or settings that are particularly confusing. It's the NLB piece that you really got to pay attention to and make sure that you get right. If you don't want all the traffic load balanced through this thing, if maybe you only want certain levels of traffic, make sure you just configure those port rules correctly. And you can do that, by getting into the cluster properties again and reconfiguring those port rules. Just decide which ports you want to be balanced, and everything else it won't play with. That way, if a server is hosting multiple services, then you don't have to NLB them all. You can just do the ones you want to. So I think we got everything. We did walk through the first half of the site-to-site VPN. We looked at packet filters and turning on tracing. Walked you through the broad steps of configuring remote access multi-site with a real emphasis on the prerequisites, the things you need to have in place, and the little areas where you can get tripped up a lot. We kind of looked at the basic setup of direct access, where to go to at least get that process in place so that you can start the fine-grained configuration, and how to set up network load balancing with an idea of making your incoming remote access connection balanced across multiple servers. I hope this has been informative for you, and I'd like to thank you for viewing.